Hi, we are done with method 1, denoting the unknown. We're going to move on to the second method, okay, the proof using congruence or similar tests. In other words, I call it simply the use of similar triangle. You'll be familiar with proving of similar triangle, alright? So without further ado, same thing, alright? Pause the video for 1 minute. List out all the necessary information from the question that can be placed inside your diagram. Okay, assuming we are done with that, you notice that there is a tangent, alright, meeting the circle at T, and there is a triangle inscribed in the circle. Alright, without further ado, I can say that this angle BTC must be equal to this angle TAC. And you want to actually find two similar triangles. Alright? Notice there is a big triangle and two smaller triangles. But the main thing that is very obvious over here would be this is a common angle for this small triangle on the right as well as the biggest triangle that you can find. And we have just listed out a pair of angles that are equal as well. Okay, so without further ado, I'm very certain we can prove the similar triangle. Let us translate what we have done on the marking into working itself. Angle ACT is definitely common. Alright, so if I were to define CTB to be X, this angle here would also, TAB would also be X. Reason being, angle in alternate segment. Notice this is the use of denoting the unknown, so that is very clear cut to me. Last but not least, ATC, which is this angle over here, from the bigger triangle must be equal to this angle TBC. Alright, reason being, that is the remaining angle in the triangle, so it's very obvious, sum of angles in triangle. So with that, we have proven a pair of similar triangle. Please write it in the correct sequence. Alright, I will start with the common angle, angle X, and the last unknown angle. So I have from the smaller triangle CTB, similar to the bigger triangle CAT. What's the reason? The use of AAA, similarity. Okay, it's very important. The next part actually shows us the product of sides. It's equal to another product of sides. And to do this, you must make use of the corresponding side ratio from the similar triangle to do the proving. How is that done? First thing, please write down all the corresponding side ratios that are equal. CT over CA is equal to TB over AT. And this is in terms equal to CB over CT. Now, with the three pairs of corresponding side ratio, you will need to check which two pairs are actually useful to you. I would like something that comprises of TA and BC. Which are the two pairs that comprise of TA and BC? TA, BC. Notice these are the two pairs that are useful. Very quickly, just have to do the cross multiplication accordingly. Notice TA is also the same as AT. So TA multiplied by BC. In this case, will give us TB multiplied by TC. Shown. And this is exactly what you need to do. Take note, you need to prove the similar triangle before you make use of the same corresponding side ratio, and choose the two pairs that will allow you to do the necessary cross multiplication.